Alrighty, good morning. This is period A6. This is Algebra 2 CP. This is May 21st. Hopefully you're all having a great, what's today, Thursday morning so far. What I would like to do for you guys today is I would like to solve a couple more rational equations with you. Before I do, just a couple of quick reminders and then a quick announcement. Reminders first. Just a reminder to make sure that your microphones are muted and your webcams are disabled, as well as you fill out the attendance form on Google Classroom. Those are the usual ones. We do also have a progress assessment that is due tonight. It was sent out on Monday. I have received about 8 of them, I'm pretty sure so far, which is well short of the number of students in the class. As long as I receive it before, 11:59 p.m. tonight, that's totally fine. But just saying, please try to get that progress assessment done. It's on solving rational equations. Okay? Now, I don't know, here's the announcement. I don't know if you noticed the email that I sent out to you just a little bit ago. I sent it out about a half hour ago. I know you had class, so you probably didn't get a chance to check your email. But I did lay out for you in detail our schedule going forward for our remaining class periods. I do have to modify our usual PA routine slightly to accommodate seniors, number one, and also accommodate you to make sure that you have enough time to actually do all of the other progress assessments. So, that being said, you got a week off last week. This week, you're almost going to get a little bit of a hit twice. We are going to have another progress assessment sent to you via email after today's class, also on solving rational equations. Specifically, the one that's going to be sent to you after today's class is going to involve a little more in distributing a negative sign, a little more in some complicated factoring, and I'll be sure to do a couple problems today that highlight that stuff for you. Okay, you may see an extraneous solution show up, things like that. But the reason that has to be done, you might be like, oh, that's a bummer. Like, why do we have 2 PAs in a row? And I understand it is a little bit of a bummer, but it needed to be done for 2 reasons. Number one, again, to accommodate the seniors, the fact that their end of the year is a little sooner than otherwise would be the case. And number two, to make sure that you have enough time to do the PAs, because if we actually kept on our current schedule, the last PA would be due on June 11th, which is after the last day of school. So I don't think we can really make that fly. So that's why we kind of had to bump things up a little bit just to make sure that we're, on a nice steady pace. Even so, I am going to make the progress assessment that I send out to you today. It's still going to be 4 problems, by the way, still 4 solving rational equations. Again, it'll involve maybe a little trickier factoring, maybe a little distributing the negative, an extraneous solution or 2 showing up. I'll highlight those types of things in the problems we do in class today. But I am going to make that due on Tuesday, that's May 26th, at the start of class. So the reason why I extended the deadline would normally be a Sunday night or maybe a Monday morning, but the reason I extended it is because it is a holiday. I wanted you to make sure you have the time to relax and enjoy your time off. But at the same time, I do think that if I send it out today and make it due Tuesday, that is an abundance of time to get it done. Even though it is kind of back-to-back, it still is only 4 problems. And the fact that, you'll have all of today, Friday, Saturday, Sunday, Monday, and if you really wait till the last minute, Tuesday morning to get that done. So I still think that's fair. It's not what I wanted to do ideally, but I think it's what we kind of have to do just to make sure we fit everything into our schedule going forward. All right. And then after that, it lays out the rest of the schedule for you. So this will be our 4th progress assessment that will be due on Tuesday. Our 5th progress assessment will be assigned at the end of next week, and it will be due Sunday night. That will be the last assessment for seniors. And then we will have a 6th one due the beginning of that 2nd week of June. All right, and that'll take us right to the end. So we're almost there. After this class, it's hard to believe, actually, we only have 6 more Algebra 2 CP class periods together. So we're going to make the most of each and every one of them, starting with this one right here. But before I dive in, does anybody have any questions about anything I've just said? Questions about anything I've just said? Going once. Questions about anything I just said? Going twice. All right, so do expect another progress assessment in your inboxes at the end of class today. It's scheduled to go out at 11:15 p.m. or a.m. p.m. It's scheduled to go out at midnight. No, it's scheduled to go out 11:15 a.m. So make sure that you check your inboxes for that. Again, it's another 4 problems on solving rational equations. And again, if you haven't done the one that was due today at the end of the day, make sure you get that done, please, on time so I can grade it, post the answers, and do all that stuff. All right. Anyway, all that aside, let's actually get into some equations now. There are a couple things that I want to point out when solving these types of equations. The first of which is just to make sure that we're comfortable dealing with the rational equations. I have 4 problems I want to show you today. The first problem is sort of just a review of what we've talked about. No fancy tricks, nothing going on there. Maybe a little factoring, but nothing besides that. The second one involves dealing when we have whole numbers and variables just kind of chilling by themselves. It involves dealing with those. The third problem really emphasizes distributing a negative, which is a very common mistake that a lot of students make. They forget to distribute a negative in the numerator of one of these rational equations. And the last problem is a problem where extraneous solutions pop up. So let's give it the best we can. Here we go. Let's start with our first example. Looks like this. X over x minus 2 plus 1 over x minus 4 is equal to 2 over x squared minus 6x plus 8. So this is a standard rational equation that we've seen before. No fancy tricks or funny business really going on here. What we want to do first is we want to go ahead and factor this down. That will allow us to, number 1, identify our domain restrictions, and number 2, actually find my least common denominator. So I'm going to do that right now. We're going to leave these first 2 terms exactly the same. And now we can factor this down to be x minus 2 times x minus 4, just like that. Okay? We can now identify our domain restrictions. It's very clear to see that in this problem, x should not be equal to 2, and x should not be equal to 4. The reason why it's those values in particular is because plugging those in results in dividing by 0, which is very bad. That's the whole root of why we have extraneous solutions and domain restrictions in the first place. Now I can find my least common denominator. My least common denominator would be, we need a factor of x minus 2 to satisfy that and satisfy that. We also need a factor of x minus 4 to satisfy this and this. Okay? So our least common denominator is x minus 2 times x minus 4. I'm now going to try to convert all of my fractions to look like that. I would like this first one to have that least common denominator. I would like this second one to have that least common denominator. And same thing with the last one here. I would love them all to match up with x minus 2 times x minus 4. So what do I need to multiply this by in order to get this? That's sort of the question. Well, I need to take x minus 2 and multiply it by x minus 4. So that's exactly what I'm going to do to the numerator. I'm going to take the x that's already there, multiply it by x minus 4. I need to multiply this by x minus 2. That's the missing piece in the middle term. So I'm going to take the 1 that's already in the numerator, multiply it by x minus 2. Just gives us x minus 2. And then here we don't really have to do anything because your denominator already matches. Now I can distribute. Gives me x squared minus 4x in the numerator plus x minus 2 is equal to 2. And the reason, again, why we only have to focus on the numerators now is because the denominators all match up. So we don't really have to pay attention to those anymore. Now we just need to make the numerators match up. Now that I see x squared show up at this point, definitely indication that I need to factor. Before I factor, of course, we want to make sure we set equal to 0. That gives us x squared. Let's see, this is going to be minus 3x. And then I'm going to subtract 2 over to this side, so minus 4. We can factor that down now, that trinomial, to x and x to make x squared. I believe we need 1 positive, 1 negative, and factors of 4 that will work out. I think that's just 4 and 1, just like that. And so this problem gives us 2 potential solutions, one of x equals negative 1 and one of x equals positive 4. But of course, before we go about our day and you know, continue living our lives, we do have to account for the one little bit of funny business going on here, and that's this. X equals 4, we established that that's a domain restriction. X could not equal 4 because it would result in dividing by 0. So we identify this solution as extraneous, and this is the one that works out for us. So this problem, although we get 2 solutions at the end, really only one of them is legitimate. the one solution is x equals -1, and this problem does have an extraneous solution of x equals 4. Any questions as to how that worked out at all? Comments, concerns, perhaps? Criticisms? Alrighty, let's move on. This next problem, like I said, I really want to emphasize what happens when you just have whole numbers and variables by themselves with no denominator. I like this problem a lot. We got 1 over x plus 1 plus x over x plus 1 is equal to x minus 2. Okay? Now, when we see variables and whole numbers by themselves, remember that we can express these as over 1, and you only have to do that if you feel comfortable doing that. If it makes you feel better to have a denominator there to represent the fact that there is something there in the denominator, then rewrite it that way. If you already know that and you can make that connection in your head, you don't really have to write over 1, but just recognize the fact that this doesn't mean that x is in the denominator or -2 is in the denominator. These are in the numerator, and they would be over 1. Okay, so that's really, really important. When you have just a whole number or a variable by itself, this one happens to have both of them, you can just go ahead and write it as over 1. Now I can find my domain restrictions. There's no factoring to do, so we should be able to identify that x cannot equal -1 here, because -1 plus 1 would result in dividing by 0. My least common denominator here is actually pretty easy. It's really just the factor of x plus 1, because I have a factor of x plus 1, a factor of x plus 1, a factor of 1, and a factor of 1. The 1 times anything works out to be the least common denominator. Like 1 doesn't really factor into the least common denominator at all. So that's why our LCD is just x plus 1. Now I'd like to convert all of my terms to have that denominator, including the whole numbers and the variables. Another common student mistake is they forget to convert these and just leave them alone. So please make sure you're doing the conversions to everything. What do I need to multiply this by to get this? Nothing. What do I need to multiply this by to get this? Nothing. What do I need to multiply this by to get this? I need to multiply by x plus 1. So I'm going to take the x in the numerator, multiply by x plus 1. What do I need to multiply this by to get this? I need to multiply by x plus 1. So I'm going to take the 2 that's already there, multiply by x plus 1. Does everybody see that? Keep in mind, another mistake that a lot of students might make is you might say, ooh, well, this denominator is already 1. So don't I just have to multiply by x in the numerator? Isn't that the missing piece, just the x? Not the case. When you have a factor of x plus 1, that is a singular factor. It's not a factor of x and a factor of 1. It's a factor of x plus 1. So we have to treat it as one piece. That piece of x plus 1 is not present here, so we need to multiply both the top and the bottom by x plus 1. Now that all our denominators match up, we can go ahead and just focus on the numerators. That gives us 1 plus x is equal to, we're going to distribute x squared plus x. Something very, very important to keep in mind, this -2 is going to distribute here and here. When you see a negative sign in front of a fraction like this, and this is going to come up in the next problem we do as well, it does apply to each and every term in that numerator. So this is really going to be -2 times x, -2x, -2 times 1, -2. Again, it's a sneaky thing that a lot of students will make that mistake and either just do -2x plus 2, they'll just multiply the 2 out, or they'll just do -2 times x plus 1 and just leave it alone, or they'll do -2x and then forget to distribute and just leave it as plus 1. Make sure that that -2 gets distributed to each and every term. Okay, very, very important. Now we see x squared show up just like before, so we're going to set up to factor. I can subtract x from this side. I can subtract 1 from this side. That gives us that 0 is equal to x squared. Let's see, x minus 2x, -1x, minus an additional 1x, so minus 2x, -2 minus 1, minus 3. We can break that down and factor now. We need x and x. We need different signs, and it looks like -3 and plus 1 is what's going to get us -2 in the middle. We've done a lot of factoring now, so hopefully that's pretty comfortable. So I get a solution of x equals -1 and x equals 3. Oh, but wait a minute. Wait a minute. Just like last time, right? X equals -1. Bad news. What's going on here? A lot of extraneous stuff. That's what's going on here. Extraneous stuff. But we do still have one solution of this problem of x equals 3. How did I know that x equals -1 was extraneous? It's again because I took the couple seconds to identify that as a domain restriction up towards the top. Any questions as it relates to that problem? All right, we're going to get a fresh sheet of paper out here. We got 2 more to do today. Ready? 2 more to do. How about this one? We got 1 over x squared minus 6x plus 8 is equal to 1 over x minus 2 minus x minus 1 over x minus 2. Okay? Hopefully you're looking at this problem and again recognizing the factoring that needs to occur. Absolutely, we have a lot of factoring to do right here. This is going to break down to be 1 over, let's see, x minus 2 times x minus 4, I believe. Right? Because that's how we can get the... That's how we can multiply to positive 8 at the end and add to the negative 6 in the middle. Now I can go ahead and try to find my domain restrictions. Here, x cannot equal 2 and x cannot equal 4. Just like, was that the domain restrictions of the very first problem we did? Oh, kind of cool. Coincidentally, the same ones. Kind of neat. But x cannot equal 2 and x cannot equal 4 because both of those values would result in dividing by 0. Very bad. We don't want that to happen. Bad news. Okay. Now I can go ahead and find my least common denominator. My least common denominator here, I need a factor of x minus 2. I also need a factor of x minus 4. If we didn't have that factor of x minus 4, this one would be very upset. This term would be like, you leave me out over here. What's going on? X minus 2 makes everybody else happy, though. Now I'd like to convert all of those denominators to match that x minus 2 times x minus 4. X minus 2 times x minus 4. I would love for this to match as well. X minus 2 times x minus 4. What do I need to multiply this by in order to make this? Nothing. What do I need to multiply this by in order to get this? We need an x minus 4. So I'm going to take 1 times x minus 4 in the numerator. It's just x minus 4. What do I need to multiply this by to get this? Again, we're missing the x minus 4, so I'm going to take the x minus 1 that's already there, and I'm going to have to do a little bit of distributing with the x minus 4. Any questions up to this point? I'll pause for a moment. No questions at all? Not even a 1. Not even a single inquiry. Doesn't look like it. Doesn't look like it. All right. So now that all the denominators match up, we can just pay attention to those numerators. Gives me 1 equals x minus 4 minus, notice there's going to be a little bit of distributing going on here, and notice that I kept this negative sign outside of the parentheses because it is going to, just like it did in the previous problem, apply to each and every term in the numerator here. So when I distribute this, I get x squared, outer minus 4x, inner minus 1x, makes a total of minus 5x, plus 4. And again, that negative sign is going to apply to each term in the numerator. Very important that that negative sign distributes. It's a common mistake a lot of students make, is to forget to distribute that negative. I'm going to get now 1 is equal to x minus 4 minus x squared plus 5x minus 4. Hopefully everybody sees that and can follow along with that. I see x squared show up, which means we have to factor. Before I even go about that, though, let's combine some like terms and clean this up a little bit. That gives me 1 equals, let's keep negative x squared. Here I have plus 6x minus 8. All right. The issue with this problem, though, or the one thing I would look at and feel kind of funny about, is the fact that we have a negative coefficient of x squared. With all of the factoring examples that we've done in class, we haven't dealt with having negative coefficients of x squared. Having a negative coefficient of x squared is not really advised before you start factoring. It just makes it unnecessarily more difficult. So what I'd want to do is I'd want to make this to be a positive coefficient. I can do that by moving everything over to that left side. So instead of keeping it on the right, let's move everything over to the left to make x squared positive. Okay, we always want to make a positive coefficient for x squared before we factor because it just makes our lives a lot easier. If it's a negative coefficient, then it's all sorts of weird. So that's going to give me now x squared minus 6x plus 9 is equal to 0. Do you see why that's the case? We add x squared over to this side, we subtract x squared, 6x over to this side, and we add 8 over to this side. 1 plus 8 is 9. Now I can break this down. This is a pretty easy factoring one, actually. We need x and x to make x squared, and I think it's just minus 3 and minus 3, because negative 3 times negative 3 is positive 9, and when I distribute, you're going to get minus 3x is minus 6x. So this gives us one solution twice, essentially, of x equals 3, which is valid, by the way. You may remember the fact that when we dealt with polynomials, if a solution showed up twice, we considered that a double root, and graphically that would mean it just touches the x-axis and curls back up or curls back down. Another word for that is to say it also has a multiplicity of 2. That is not super relevant for our discussion right now, but just know that this one solution, it is possible for one solution to show up twice like this, and this problem has one solution of x equals 3. Any questions about that at all? We got one more to do today. The last rational equation that we're going to do together. We're ready for it. We're all strapped in. We're all geared up. Everyone's like, sure, Mr. Giorgio, whatever. Do your thing, man. All right, we got it. We'll do it. We'll do it. Okay, here we go. Last one. We got x over 6x minus 36 minus 9 is equal to 1 over x minus 6. Okay? This is a good problem. It kind of encapsulates everything that we've talked about so far. All right. First things first, it may be a little deceptive. You may not notice it right away, but there is definitely a greatest common factor thing going on here that we could do in the denominator. We could take out a GCF of 6 in this problem, leaving me with x minus 6 minus 9 over 1, if you prefer, equals 1 over x minus 6. Does everybody see how we did that? We can now identify our domain restriction. Our domain restriction is that x cannot equal 6, because 6 minus 6 is what would result in dividing by 0, right? Same thing over here. My least common denominator now, we need a factor of x minus 6, because that makes this happy and this happy, but this one also has an additional factor of 6. So we need to account for that. We need to say our least common denominator is 6 times x minus 6. Otherwise, if you just left it as x minus 6, this one would be like, well, wait a minute. I have this extra factor of 6 here that you're not accommodating me for in the least common denominator. Okay, it needs to be a common denominator, meaning everything needs to, have something in common. So now we can go ahead and convert. I would love all my denominators to now match, oh, sorry, not x, 6, to now match that least common denominator. So I ask, what do I need to multiply this by in order to match this? Well, we don't need to multiply it by anything in this case, so we're just going to leave x by itself. What do I need to multiply this by in order to get this? The whole thing, right? So I'm going to take the negative 9 that's already there, multiply it by 6 times x minus 6. You might need a little calculator help for that. And lastly, what do I need to multiply this by in order to get this? I need the extra factor of 6, so 1 times 6 comes out to be 6. Everybody following along why that's the case? Notice why we would need to multiply the whole thing here. Yes, because there's nothing there now in the denominator. Now we can just pay attention to the numerators, that the denominators all match up. I get x minus 9 times 6 is 54, so we'll leave it as minus 54 times x minus 6. I'll distribute that in the next step. Equals 6. We can now do some distribution. This gives us x negative 54 times x, so minus 54x. And negative 54 times negative 6. Where's my good old handy-dandy calculator? Bam. We get 324, right? Oh, throwing things. Getting excited. We got 324. That's equal to 6. Slightly bigger numbers than we may be used to seeing in equations like this, but we can just go ahead and, it's really just algebra 1. We can solve for x normally. X minus 54x is negative 53x. Move the 324 over to the other side. That's going to be negative 318, I'm pretty sure. And if I go ahead and divide, we got negative 318 divided by negative 53. Oh, that's 35. Whoops. Negative 318 divided by negative 53, not 35. I get my solution of x equals 6. Hooray! A solution of x equals 6. And I'm done, and I'm happy, and I can continue about our day, right? Thank you so much for your attention and focus today. I hope you learned a lot this... Whoa, wait a minute. Wait a minute. It just occurred to me. X equals 6. That's an extraneous solution because it's our domain restriction. Everyone's like, oh, God, Mr. Giorgio, jeepers. I can only handle so much cringe for one day. But it's still true. This right here, we can't put a check mark next to it. This doesn't work. This is extraneous, right? So now what? Our one and only solution was deemed to be extraneous. So what does that mean? Well, what that means is our problem has no solution in this particular case. Which may be disappointing, a little bit of a disappointing outcome that you do all that and you get no solution. But no solution is still a valid response to a problem like this. You're declaring, hey, this problem has no solution. It should still be a satisfying feeling. The reason there is no solution is because you've run out of options. You did your algebra. You found x equals 6. That solution is extraneous. We're now out of options, so we've nothing left to say except no solution. All right? So it is possible to get problems that do have no solution if all of your potential answers that you come up with prove to be extraneous. Alrighty? Alright, now we're ready to go about our day. Does anybody have any questions or concerns regarding anything that we've talked about today? Anything at all? Sean coming in the chat saying a big old nope. Alright, great. Well, just a reminder, you do have that progress assessment that was assigned on Monday that is due at the end of the day today, so it is due tonight. Make sure you get that done. There is going to be the follow-up one sent out to you via email today, and that will be due by the start of class on Tuesday. Okay, that's plenty of time to do it. Please don't wait till the last minute. Try to get it done as soon as you can, especially while this stuff is fresh on your mind. I'll try to get this video uploaded as fast as I can to make sure it's there for you so you can look back at problems like these if you need some refreshers. All right? Again, reminder about Miss Mao having office hours, a great resource. She also has been posting some fantastic notes, so please make sure you check those out as well. But other than that, thank you for everything today. I hope you have a fantastic Memorial Day weekend because I will not see you tomorrow. And good luck on everything, all right? I'll see you then. Bye, everyone. Have a great day. Reese, Sean, have a fantastic day. See you guys.